Happy Friday, everyone. Welcome to CyVerse's final webinar of 2024. I'm Tina Lee, CyVerse's User Engagement Officer. We are pleased today to host our final webinar of the season, Geospatial Data Analysis using CyVerse, presented by my colleague, Dr. Jeff Gillen. Let's first take care of some very light housekeeping, and then Jeff will take over. Today's webinar is about 30 minutes long, time at the end for your questions, and feel free to ask questions. Please open your Zoom chat window and you're welcome to type questions there, although with this small group, we can probably just unmute everybody at the end and go for it. As always, we record our webinars and I'll post the video recording along with Jeff's slides on our website and on our YouTube channel. And now I'm pleased to introduce Jeff. He's a research data scientist and educator at the University of Arizona's Data Science Institute. Jeff leads a variety of technical workshops on open science skills, cloud-native geospatial, and AI tools, and has 17 years of geospatial experience in the realms of applied research, government, and contracting. His core expertise is executing multi-scale imagery from drones, airplanes, and satellites for land and resource investigations. He is currently interested, or I should say specifically interested in cloud-native geospatial to scale reproducible workflows and data sharing. Welcome, Jeff.
Thank you for having me, Tina. Thank you for the introduction. Glad to be here in the final webinar for CyVerse. So I was going to introduce myself, but you did a much better job than I could do, so I appreciate it. So today, we're going to talk about all the kind of geospatial stuff, services, activities, all the things you can do geospatial-wise on CyVerse. So if you've never used CyVerse before, I would describe it as a very large cloud computing system. It's housed here at the University of Arizona. It's free for all U of A personnel, faculty, students, staff can use it to their heart's content. It is a wonderful platform for computing, for data storage and data sharing, and it makes it ideal platform for a lot of geospatial stuff. So this is going to kind of be a tour of just a bunch of different things that I've been doing and my colleagues have been doing with geospatial and CyVerse. Yes, you already introduced me pretty well. My name is Jeff. Over here on the right, I have a little kind of bio resume. So yeah, I've been doing geospatial for, I guess, since about 2007. My first jobs in geospatial were with the National Park Service, where I was a GIS analyst in Petersburg National Battlefield. And I also worked as a cartographer at Yellowstone National Park. That was back in 2010. So those are kind of my roots in land management and ecology. My first real professional job was at USDA's Agricultural Research Service in Las Cruces. That was at New Mexico State University. And that's where I really got into aerial imagery. Started in 2011. I was introduced to their drone program and got into it pretty heavily, have been doing drone stuff ever since. I came over here to Tucson in 2015, got my PhD, worked for my department there for a while, and then have been at CyVerse since 2022, doing a lot of education around data science and learning a lot about it myself. So yeah, here's the tour we're going to do. Basically, we're going to talk about several different things, the geospatial offerings that we have here at CyVerse. So we'll talk about data storage. We'll talk about how you can get a permanent DOI for your publication or your data set. And we'll talk about how to really share out your data from cloud storage into by using things called cloud native formats. We'll show some examples of geospatial apps that you can launch in the CyVerse discovery environment. Talk about spatial temporal asset catalogs, which are a type of metadata for describing geospatial data. Then we'll talk about some of the things we have in terms of software services. So we have a campus-wide license for planet satellite imagery. We also have a whole lot of licenses for using a photogrammetry software suite called Agisoft Metashade. And then finally, I'll talk about the data science workshop series that have been leading and we'll do another iteration of in the fall. Okay, so that's the roadmap. So let's start with storage. So remotely sensed imagery, GIS data, all these geospatial data formats are classically big. I'm in the world of aerial imagery, and it's very easy for me getting into the tens and hundreds of gigabytes and terabytes of data, actually fairly easy. So geospatial data is large, and CyVerse is kind of a perfect platform to house that stuff. So the data store that we have at CyVerse is an object cloud storage, and it's similar to something like Amazon's S3, Microsoft Azure, Google Cloud. So it's similar to those commercial cloud providers, but we are in the world of research and academia, so it's a lot cheaper to do it with us. Free, in fact, if you're a U of A person. So you can get a pro account and get 3 terabytes of storage, and that's usually does it pretty well for most people. And the beauty about our storage system is that it can be shared out to anyone within the CyVerse system or anyone publicly. You can share it on the open internet, and it's just a great way to share data and store it. And we have several different ways to get data in and out. If you have super large data sets, we've got some fancy tools. Things like CyberDuck, things like Go commands for data transfer in and out of our data storage. Okay, so also along the lines of storage is we have something called the data commons, which is kind of our public facing storage, and it has more of a permanent feel to it. So the data commons has kind of 2 components. It has something called community released. And so this is a directory or a folder that we can create for you that you can have data that you think might be of interest to other people. And then it's basically shared publicly, so anyone else through CyVerse can get into it, read the data or write it, depending on what kind of permissions you give it. And then we have something called curated data sets. And a curated data set, I often like to think of it as something like a permanent kind of fixed in time product. And it's most associated with publications. So if you publish some kind of science, the data set that goes along with that science can be put into a curated directory, and it can kind of be a permanent home for it, and it can have its own DOI or digital object identifier. So it will kind of stay there permanently, and you can reference and give these DOIs out to other people who might be interested. So the curator is just like a nice place to kind of park that data, usually is associated with a scientific publication. So I'll just click on this link. This is just an example of some research that I published back in 2019. I did a very large drone data collection for rangeland monitoring, and I made a publication out of it in a journal called Ecosphere. And so here's basically things that got a DOI. I just put all my data in here in some kind of organized way, and then I can just share it out.
Jeff, all we're seeing is your slide. Did you click on that link to show?
I did. What did you guys see?
We're just seeing your slide with the link on the bottom, and it just
Okay, so
yeah, so
I'm changing. Obviously, it didn't show.
okay.
New share desktop 1. What do you guys see?
Same thing. I think you have the whatever it's called, the share view or screen view or something. So we're not even seeing your other tabs because you're probably switching tabs, right?
I am.
Yeah. You might have to go out of presenter mode.
Yeah, it's amazing how often this doesn't work. Okay, what do you guys see?
Now we see, yeah, community release curated, so there you go.
Now you can see it.
Can you?
Okay,
Yeah.
hopefully that doesn't continue to be a problem, but it might be. Okay, so that's all I wanted to talk about when it comes to data commons. Great place to store and share your data in kind of a working way or in a permanent archival way. So finally, or not finally, but next I want to talk about cloud native formats. So a big kind of interest of mine is sharing out data, sharing your data with the world. And there is geospatial formats now that we call cloud native, and they are specifically designed and built for internet access, streaming things over the internet. And so these are data formats that you probably heard of, but they're just a little bit different. You know, when it comes to raster imagery products, things like GeoTIFFs, when it comes to LiDAR or photogrammetry point clouds, things like LAS. And so all of these kind of classic geospatial formats, in the last few years, there's been a push to change them a little bit. And so it makes them much more streamlined, I guess I would say, for them to stream across the internet. It makes them much more shareable. And so we're trying to get away from this, the model of downloading data to your own machine. You know, geospatial data seems to be getting larger and larger all the time. And a lot of times I may not want to download a 5 GB image from somewhere. But with these cloud native formats, I could just stream that cloud native format over to me, over to my application, and not actually have to download things. So that's kind of the idea behind it. We can just keep data up online and we can work with it on the internet without having to bring things locally to your own machine. And so the CyVerse data store is kind of a perfect place to park that. When imagery is in a cloud native GeoTIFF, or point clouds are in a cloud optimized point cloud, they can be streamed directly out of CyVerse storage into any application. So it's really really great efficiency to work online. And yep, I said that before. So it's about moving data, sharing data without having to download it. So let's see some examples of this. So these are the logos. So cloud optimized GeoTIFFs are specifically meant to be streamed over HTTP, or we call that a COG. And then there's a COPC, the cloud optimized point cloud. ZAR is for large multi-dimensional array data. So it's similar to HDF5. When it comes to vector, there's something called flat GeoBuff, which is also similar in concept. GeoParquet. So these are all formats that can be streamed from cloud storage, i.e. from CyVerse, directly into some other application. And let's look at some of those applications. So for example, from cloud storage, you could stream it directly into QGIS. You could stream data directly into a Jupyter notebook if you're doing something in the Python ecosystem, or directly into web applications. Let's look at an example here. So if I click this, I wonder if you guys will be able to see it. Can you see the new tab opening up?
Mm-hmm.
Yeah?
Yeah.
Oh,
Whoa, yep.
Okay. So what we're looking at is a drone-based photogrammetry point cloud. And this point cloud is a cloud optimized format. Okay, it's sitting in the CyVerse data store and it's being streamed to this web viewer. And so I didn't have to download anything. Yeah, so this is a golf course up in Phoenix that I did a drone flight with about a year ago. So yeah, this is an example of a cloud optimized point cloud that I can stream from cloud storage out to, in this case, it's a web app viewer. But you could just as easily stream it into a Jupyter notebook if you wanted to do analysis. You could stream it into QGIS if you want to do some other kind of analysis. All right, let's look at this other example here. This is an example of a cloud optimized GeoTIFF or a COG. So same same concept. This orthomosaic is sitting in cloud storage in CyVerse. And let's see how long it takes for it to tile up here. Here it goes. It's sitting in cloud storage and it's being streamed to this web application called COG. I think it's COG.io is the name of this web viewer. So just as easily we could stream it to any other application. Okay, so those are some examples of what we call cloud native formats. And CyVerse is a great storage place to park your data and then share it out with colleagues, with friends, with anyone that you might want to share data with. Then we will move on. So similarly, along the lines of sharing your data with the world, we are implementing something in CyVerse called Spatial Temporal Asset Catalogs, or STAC is kind of the acronym for it. So what is STAC? STAC is basically metadata to facilitate the discovery and sharing of geospatial data. The metadata, it essentially consists of JSON files or GeoJSON files. And it also consists of a standard API. And so this is what a GeoJSON looks like. You know, it's kind of boring. It's just it's a text file that can be read by browsers very, very well. But what STAC is it's kind of I'd say a movement amongst a lot of geospatial people around the world, a lot of companies, a lot of government organizations that are all trying to find a common way to describe geospatial data and then share it. And so that's what STAC is trying to use this JSON format in a standard API format. And so if everyone starts to use the same format, then essentially we are building one giant worldwide catalog of geospatial data. So this graphic is me trying to conceptually explain it. And so we have some cloud buckets here, and one of these cloud buckets could be CyVerse. And so you could have your geospatial data on CyVerse, and then we can describe it with the STAC protocol. You know, we would apply these JSON metadata standards to it. Or we could serve it in our own STAC API. We have one of those. And the idea then is that if everyone has geospatial data across the world on their own servers or their own cloud storage, if we all describe it using STAC, then we have one big catalog. But there still needs to be kind of a centralized place. Like, where do I find these catalogs? Well, it's already been built. There's something called the STAC browser and something called the STAC index. And those are kind of like the centralized places, the hub, if you will, to find out where all these other STAC catalogs are. And so there's a lot of people out there, a lot of groups that are kind of have adopted the STAC catalog standard. NASA's doing it, Microsoft Planetary Computer, Google Earth Engine, satellite companies like Maxar, Planet, Satellogic, USGS, European Space Agency, Open Topography, and I'm sure there are a lot more. You know, so it's really gaining momentum in terms of a standard way to describe your data, which makes it so much easier for other people to find it. So we actually have a STAC API. And so if you have geospatial data on CyVerse, we can apply this metadata stuff, and then we can create something like this. So this was a project I did. This was my drone project. You know, I collected a whole lot of drone imagery just south of Tucson, and I want to share it out. And so I've applied STAC metadata to all of my drone imagery, and now I have this nice kind of visual, this nice little web viewer so other people could browse through it and find something of interest. Example, you could click each of these little boxes here, and those represent the footprints of drone imagery products. If I was interested in that one, I could click on it, and then I could find, the actual assets, like the imagery products that I made from it, including canopy height models, digital surface models, terrain models, and orthomosaics. Over here, we have some basic description of what these imagery products are. This could be built out a little bit better, but the idea is that we're building standard metadata, and we can do this directly in CyVerse. Keep going. So I've got about 10 minutes. I know we're going rapid fire through each of these things, but I just kind of want to hit the highlights. So another thing to mention are the geospatial apps that we can launch. So when I say what is CyVerse, I usually tell people it's large cloud storage, store your data. But then we also have something called the discovery environment, which is a place where you can launch software applications. You can launch a cloud instance of many things. So when you launch apps with CyVerse, you have access to large computational resources, a lot of CPUs. We can give you access to GPUs also, lots of memory. And then you can launch these apps in something called containers. And so in the geospatial world, you can launch cloud instances of geospatial Jupyter notebooks. So we have specific Jupyter notebooks that already have a lot of geospatial packages installed. Same thing with RStudio. And then QGIS. So we can easily spin up an instance of QGIS, and you can use it directly in your browser and have access to all of your data that's in the data store. So it's just like using a computer. You can just launch it from your laptop somewhere, but then you have a lot more storage and a lot more compute than you would on your actual laptop. So that's the idea. Here's just a screenshot of a cloud instance of QGIS that I launched yesterday, just to make sure it worked. It does. Okay, and so let's get to the licensing that we have as a service to pretty much anyone at University of Arizona. So we have a partnership with Planet Satellite Imagery Company, and we have purchased a large campus license. And so we've spent a little bit of money, and we've given access to pretty much any University of Arizona personnel has all kinds of access to free satellite imagery. If you are interested in this, you can, oops. Oh yeah, I put it there too. Previous, back. Okay, that didn't work. All right, we're back. If you're interested in getting free imagery from Planet, you can check out this link right here. This will land you on a page where you can then sign up as a student or sign up as staff or faculty at U of A, and we can get you a user account and you can start getting data from Planet. So this slide is showing you kind of all the resources that are available to you through this campus license. You can get PlanetScope imagery. That's probably the most common thing. It's a 3-meter resolution imagery. It covers the entire globe, and it's just being churned out day after day after day. So that is really like a huge gold mine of imagery if you are interested in satellite imagery. But also, there's another satellite constellation called RapidEye that's available to us. There's something called SkySat, which is a higher resolution. I think it's finer than 1 meter in resolution, and we can actually do tasking. And so if you really have somewhere you want to point a satellite, we can probably do that. And then the other kind of stuff that we have is something called planetary variables that Planet makes. And it's basically they take satellite imagery and then do some kind of analysis to create an imagery product. So for us, the interesting things might be soil water content, land surface temperature, or forest carbon. So all this stuff is free if you're a U of A person. Okay, and then the other licensing that I wanted to mention is we have a whole lot of licenses of a software program called Agisoft Metashape. And it is probably the premier, the best software out there for photogrammetry, for aerial imagery, and I have used it extensively for drone imagery. And so from a series of overlapping two-dimensional aerial images, you can make just beautiful and very accurate three-dimensional models and three-dimensional imagery products like point clouds. And then from those point clouds, you can make terrain models, you can make canopy height models, you can do the whole suite of imagery products all through Agisoft Metashape. So it's a really fantastic product. And we have, I think 20 floating licenses. And the idea is that you should use them on U of A's high performance computer or use it through us, on a cloud system. And I personally have done this. And so the beauty of using on the HPC or cloud is that you can run multiple instances together. So instead of just having one computer trying to do your photogrammetry, you could have 10 computers all working simultaneously to do your photogrammetry. So it becomes kind of a several orders of magnitude faster when you are processing through large amounts of aerial imagery. And that is all free and available to anyone at U of A that's interested. All you gotta do is reach out to us and we can make it happen for you. Okay, and the last thing that I want to mention in terms of geospatial is a data science workshop series that I lead. And so I call it Next Gen Geospatial. And I did this for the first time this past spring, and it was a lot of fun. I learned a lot. Hopefully my students learned something. And so what I'm doing in this workshop series is just trying to work more with open tools. It's more about programming. So we're using a lot of Python. We're trying to do a lot of things with cloud native, doing a lot of things on the cloud. And so over here on these topics, these are all the things that we covered and are probably going to cover again in September. We covered how do you get data through APIs. How do you use cloud optimized geotiffs? How do you make them? How do you use spatial temporal asset catalogs? And some of my most popular ones were how do you use Google Earth Engine? How do you use Microsoft Planetary Computer? I did one where we talked about how to make a containerized pipeline. We had a representative from Planet come and talk about the campus license and like all the cool things you can do with Planet satellite imagery. And then this past week, I gave one on deep learning in terms of how do you identify trees from drone imagery. So we'll do a similar type of curriculum starting September 3rd, this coming fall. And so if you're interested in this stuff, you can look down on these links right here. This GitHub link is the actual content. And so that's where we keep, our workshop content. We just keep it here on GitHub. They could also go to the Data Science Institute website, calendar, and that will then show you the times and dates and everything you need to know to find and attend these workshops. So I think I've come to the end. I know that was a big scattershot, and hopefully you guys have learned a little bit more about the geospatial offerings here at CyVerse. Is there any questions or any comments that I can field?
Please feel free to unmute yourself and just fire away at Jeff.
Hey, Jeff, my name's Larry Head. I do things in transportation, and I wonder if you're able to create plots where you have like a trajectory. Say if you went on a hike and hiked a trail, you'd have waypoints along the way, or for us, it's vehicles traveling down roadways.
Okay, well, I'm not sure I quite understand the question. I mean, CyVerse is a large computing system. So anything you can do on any computer, you can do with us, but with larger storage, larger computation abilities, and better ways to share it. So if what you're saying can be done on a computer, for sure.
I was wondering about tools because we have a ton of data on CyVerse, and we've created some Jupyter notebooks and done things on our own to visualize the data. But I was wondering if some of these packages deal with that trajectory data.
I don't think specifically. I
Okay,
don't think we have something like that's been pre-prepared to do that. That sounds like a Python endeavor. in,
yeah,
in my
that's
in
what we
my
do.
estimation. Yeah, okay. But yeah, we don't have anything like pre-made to do something like that.
Great, thanks.
Are there other questions for Jeff?
Jeff, thanks for the great presentation. I appreciate it. I'm kind of a noob to this stuff, and it's very informative. Um, I'm with the U.S. Forest Service R&D,
Yeah, we've
and
met.
yeah, that's right. We did
Hi, Kurt.
the FOSS workshop. I
Yeah.
remember. So things are proceeding slowly but surely in the agency. I wanted to mention that after doing a short talk supported by two people you probably know, Chris Wood and Larry Wiegand on the Forest Service side, their contributions to this short talk generated a lot of interest among some researchers who use geospatial data in particular, the different kinds. And the first question that all of them asked were, is this going to work with data that I'm already working on Google Earth Engine or Amazon Cloud or whatever, or it's on the University of Washington's HPC. And so the main questions were not about would they use it if it was available, but rather, will the data storage and transfer be as to them easy as it was before? Oh, and then another question, the fall workshop seems to answer a lot of questions about that. Is that open to government agency people, or is that just a U of A thing?
The
Thank you.
workshop's it's open to anyone. It's free and available. I mean, it's targeted, I would say, to U of A people, but it is certainly open to anyone else. I have a number of regulars that come that are not at U of A, and it's just fine. So anyone, including yourself, is certainly welcome to attend those data science workshops. Okay,
Okay.
yeah, so to answer your question is about transferring data between CyVerse and then other computing systems, like an HPC in Washington, am I correct?
Yeah, but more generally, just a cloud service somewhere. And the person, I'm asking this question because I don't use those services. And I was trying to answer that question from people who do use those services, if that makes any sense.
Yes.
And just hearing your presentation, well, I'm just reporting that that's the first question that people ask.
Okay, so what you're saying is like their data is already somewhere else, and they're like, how easy would it be to get my data where it currently is over to CyVerse,
Yes,
or
exactly.
vice versa?
Exactly.
There is a number of ways to transfer data, and I am not the expert data transfer engineer, but we have several in-house. There might be one on this call that maybe knows a little bit more than me. But that is a very common question and something we deal with day in and day out. Is how do you get data from here to there? And it typically can be solved pretty easily. And of course, it depends on the application. If all your data is on an HPC, yes, it would need to be transferred in some way to CyVerse if you're interested in storing it here. But using these cloud native formats, the data could just be sitting in CyVerse and then be streamed out to other places for analysis. Your data could be sitting in CyVerse, and a GeoTIFF could be streamed out to a Jupyter notebook somewhere else, or a web application somewhere else. And so that's kind of the beauty of these cloud native formats is it almost the geography almost doesn't matter as long as they're on the internet somewhere. And it makes it so much easier to just move around the internet wherever they need to go.
Okay, thanks very much.
You're welcome.
Any other questions? Okay, well, thank you, everyone. This is the last, as I mentioned, the last webinar of the spring semester. And so we'll be on hiatus for summer, but we're working on a new lineup for the fall involving ML, AI topics, and more. So, and as Jeff has said, you all are welcome to go to the Data Science Institute website and peruse their webinars and workshop offerings. So thanks for attending, and we will see everybody hopefully in the fall. Thanks, everybody. Thank you, Jeff.
Thanks for attending, guys.